close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. silhouette. I'm getting stronger step by step. The clock is ticking, but there's no time for me. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We'll fly above the sky. We are heroes tonight. Feel like a dynamite, ready to explore right up in the sky. I need you to listen, I need you to hear, and don't show. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
That's good.
Alright everybody, it's time to just talk. As simple as that. I've learned quite a lot. Okay, the OOP section is done, so I don't need to worry about that. Ultimately, I know about inheritance, polymorphism, abstraction, and what is one, encapsulation. Okay, so don't need to worry about anything as such. And right now it's time to actually just go through those things and make sure that we know actually the things, whatever we have learned. So let me even save this code, whatever I have written over here. This is code is gonna be extremely important. Ultimately, it is kind of my notes, so I need to just make sure that it is just saved well somewhere or the other. And slash page class code slash code, and I will be pasting it over here. So ultimately this is the code that I will be using for revising the things and all. It's actually a lot, but ultimately quite good stuff over here. I have mentioned most of the things that I learned, and I hope it's gonna be helpful. By the way, all the things are in Python, so instead of having this, I will be having just Python language over here, so that things are quite clear. Just comments are gonna be looking like comments, and other things are gonna be looking like the way they are. So ultimately this is all that we have done so far. And as for going through it all, I will be just solving some of the questions using these things only. And before that, let's go through the fundamentals. So object oriented programming is something that we are gonna be discussing over here. And let's close this particular thing. Let's create another file inside it. So I have oops.py. I will have another something called by the way, I'm using venv over here. That is kind of an environment inside that you can create packages like Python files, and all the packages that you install will be installed inside this particular venv environment only. By the way, this is gonna be practice.py. Again, we will be practicing the things over here, that whatever we have learned so far, and this is how it's gonna be going on. So what is the object oriented programming? So I'm gonna be just reading out. I have a PDF and I have some content in that, so I will be reading that out, and let's see how this is gonna be going on. Let's suppose we need to build a software to store all the information related to students studying in our college. These students could have a lot of properties like names, parent names, addresses, graduation year, CGPA, etc. associated with them. They could also have a lot of behaviors like a fee payment, scholarship, calculation, checking minimum attendance criteria, etc. associated with them. Without existing Python data types, we can choose to store this information in lists, dictionaries, but that would not be efficient, as we have a lot of properties. We'd have to create too many lists and it will be hard to keep track of them. If we use dictionaries, we'd have to redefine the same keys again and again, and we won't logically be able to associate behaviors with that data. So to simplify our work of creating such a software, we have object-oriented programming, which gives us the concept of classes and objects. Having said that, there can be a way that we can create a function, and that function actually creates the dictionaries, or that function actually creates the lists and all. But again, that is not the most optimal way, and that is why we choose to go with the classes, because there are two types of things: object oriented programming, and there is procedural programming. So when it comes to procedural programming, so at that time we deal with functions and all, that does the job. But when it comes to classes, so they actually define it in a better way, they give it a better structure, they make it work with the things easy, and that is why they are used for. Let's talk about object oriented programming. That is called, of course, OOPS. So object-oriented programming in Python is a programming paradigm centered around organizing code into objects. We will be organizing the codes into objects. We will be creating the instances and all. Bundles of data, attributes, and behavior methods. It helps us structure program in a way that is modular, usable, and easier to maintain. It's not compulsory to always use OOP concepts, but they definitely help in a lot of cases. The thing is that first of all, you will have to instantiate the class. That means you will get the object, and on that particular object you will be calling the methods. So what is the class? We have just two things in the class. One thing is attributes, like we have instance attributes, we have classes attributes, but they are inside the class. And then we have methods. We have different types of methods. One is instance method, second one is class method, and third one is called static method, that neither belongs to class nor belongs to attributes. not belongs to instance, rather that is just a simple method, static method that is meant to do some kind of job, maybe calculation stuff, maybe just adding in all, anything, depends whatever you want that to do. So it's just like that. OOP models software as a collection of interacting objects, similar to how we think about real world entities. OOPs models software as a collection of interacting objects. What it does, when it comes to OOPs, so it is all about modeling software as a collection of interacting objects. So it will make lots of classes, and then when we instantiate those classes we will get lots of objects, and OOP is all about modeling them in the best way possible so that they are easier to maintain, similar to how we think think about real world entities. Each object represents something meaningful in our program, such as a user, a car, a bank account, or an enemy in a video game. And the best thing is that when it comes to Python, so at that time in Python everything is an object, whether we talk about string, list, integer, float, boolean, list, dictionary, set, tuples, doesn't matter what you think talk about. If you just get the type of that, you will see that everything is a class. By the way, for just an example purpose, I would like to show. Suppose I have this tuple over here. So tuple is gonna be equals to how? I think this is how we create the tuple. Let's first of all print the type of it. I just hope this is it. And I'm not able to format it better. What is the problem? Control. Why am I unable to format it? Format document with a block formatter. Well, it should be fine. Let's get rid of this particular thing right now. And what I want to check that print a type of t. That is it. Not like this, just like this. And let's try to get the result of it. So I'll just simply run the program. And over here I'm getting that tuple, and I'm not only getting tuple, I'm getting class tuple. That means tuple is a class. So this is the thing that is something interesting to know about. Like in Python, everything is a tuple ultimately. So this is how we can just simply go ahead. Just a sec. Alrighty, let's continue from here on. And then when it comes to in Python, OOP is based around classes, which are blueprints for creating objects. That's great. What are classes and objects? A class is a blueprint or template for creating objects. We can think of a class as a recipe. It describes what an object will look like, its attributes, and what it can do, its methods. But it is not the object itself. The thing is that even when we talk about class, the class itself doesn't take space in the memory. Rather, when we instantiate the class, when we actually, because the class is just a blueprint, so when we use that blueprint, and using that blueprint, when we create actually some data, that particular data gets saved in the memory. So class itself doesn't take any space, rather the instance of the class that takes space in the memory. So this thing, we need to keep this particular thing in mind. By the way, this is how I can make a class. That's okay. And it has its what is this called, instance attribute. I think this is the class attribute. Sorry, let's go continue from here on. Object, an object or instance. Okay, whether we call that object, whether we call that instance, we call methods on the object. So we call the methods on the instance, you can say. We call the methods on the object, you can say. It's up to you. So an object, or we can say an instance, is a realization of a class. Realization in the sense, when we instantiate the class, at that time we get the object can be called an instance. It is the actual thing created based on the class blueprint. Now based on the template, we can create as many objects as we want. Once we have created the template, like once the class is created. Hello Dhruv, good to see you bro here. So once we have created the class, at that time, that is just kind of a blueprint. So using that particular blueprint, we can create as many instances, as many objects as we want, and this is how we can just simply go ahead. By the way, I can create car1 and car2, etc., and then I can just keep going on. Use the dot operator to access the properties and method. That's great. Class versus objects, pretty simple. Class is a blueprint or template. When it comes to object, an object is a concrete instance of a class, ultimately concrete value. Class is just a normal blueprint, and instance is the real thing that you have created using the class. So an object is a concrete instance, real value of the class. And when it comes to class, so does not exist in memory until instantiation. The thing is that we instantiate the class, then we get the instance. Before that we just write the code. So class code is just a code. It does not take any space in the memory. So when we instantiate and then we get the instance, that particular instance take the space in the memory, contains actual data. Ultimately, yeah, instance contains the actual data and it actually occupies the memory. And when it comes to class, so one class can create any number of objects. Any number of objects in the sense, one you have created the blueprint, then you can instantiate the class any number of time and you will get lots of call. What does that mean? Like, do you wanna get in touch or something? One class can create any number of objects and all. Ultimately we can create many instances and each object is independent. Like, we can create many instances, but all those instances are gonna be different from each other. They will have no connection with each other at all. Let's talk about attributes and methods. When it comes to attributes, attributes are variables and methods are functions defined inside a class. We can dive deep into it. The thing is simple. Attribute means whatever variables you have, whatever field you have, field values, whatever values you have inside classes, they are called attributes. And when it comes to methods, so usually we use functions. Normally today you learned Python and a few days back Munstack. Can you please explain means your path of learning? I just joined your channel few days ago back. The thing is that everything I learned that is around full stack. So ultimately I am a full stack developer. I want to build website. I learn full stack, of course. Then I work on full stack projects. Then I currently am learning Next.js as well, so that I can make full stack projects better. Then I'm learning about DevOps so that I can actually deploy that full stack project on an EC2 machine. And lastly, I'm learning Python so that I can actually integrate AI. Mainly I want to learn about Gen AI. I hope generative AI. So I can integrate AI in my full stack projects. So it may seem that I'm learning different things. They are actually different things, but at the end of the day I will be getting them connected to the one thing, that is full stack. So in my website I want to use all these technologies, and that is why whatever amount of time I'm getting, at least I give 3 hours to one thing and then I switch to another one. And I think giving 3 hours is enough in a day. So for 3 hours I work on the project and then I switch to DevOps, then I switch to Python, then I switch to Next.js. This is how the things go on. I hope you got that. But yeah, I learn everything every day. It's not like I leave anything, even if I just learn a little. Okay, attributes are variables and methods are functions inside a class. That's okay. Let's talk about the constructor. So in Python, it doesn't matter in Python, in Java, in JavaScript, in C++, doesn't matter which language you talk about, we have constructor in them, we have oops in them. So in Python, a constructor is a special method used to initialize newly created objects. Constructor is a special method used to initialize newly created objects. It is not responsible for creating the object. Instead, the constructor sets up the object with initial value. The thing is that constructor is used to initialize the object, but it does not mean that it is completely responsible for that. You instantiate the class. Constructor helps you simply give the arguments, and those arguments it simply assigns to the instance field. Great, buddy. And Gen AI is trending nowadays. Keep going. Thank you very much. And that I haven't started Gen AI yet. I'm still learning about Python. I learned it long time ago. Right now the revision thing and all, you can call it, that's going on. But yeah, trying my level best. Okay, we use this self method to define our constructor. Whenever we create an object of class, Python automatically calls init method. So ultimately, with the help of the init method, we ultimately create the constructor. And whenever we call any instance, or in simple words, whenever we instantiate the class, that means we actually call the class, we create a new object of the class. At that time, constructor gets called automatically. As simple as that. So I have a class, I have a constructor, and this is how I can call it. Let's talk about self. Mainly when it comes to self, it simply references to the instance itself. There are two things. First of all, there are instance attributes and there are classes attributes. When it comes to instance attributes, so there is something called self parameter that simply references to the instance. That means if you write self.name, so that is self.name belongs to the instance, not to the class. So self is a special parameter which refers to the instance of the class, not to the class. If we want to refer the class, then we will have to use CLS. We can directly use the class name. So if the class name is student dot name, something like that, we can directly use the class name. Self is directly used for simply refers to the instance itself, that is calling the method. So self is a special parameter which refers to the instance of the class that is calling the method. Which instance? Of course, what the hell, just a sec. Self is a special parameter which refers to the instance of the class that is calling the method. Okay, the thing is that you will have self in a method, right? A method in the sense function. So a function inside the class that is called a method. So self is going to be used over there. So either you will get self in a constructor or in any methods inside the class. So what it is saying that self is a special parameter which refers to the instance of the instance of the class that is calling the method. So whichever method we are calling, Zohab, good to see you here. So whichever method we are calling, self get passed to that particular method automatically. So it is compulsory thing. Like suppose you have a class over here, it's gonna be like that. Suppose I have a class called student, and inside this class I can create a constructor too. So in it, that's gonna be a constructor, and it's gonna be like this. Over here I have to just write self anyhow. Why am I having to write self by default? Because whenever I call the constructor, whenever I instantiate the class, at that time self automatically get passed. So self need to be there. Apart from self, you can just have another values, like you have name and all. It's up to you. But self need to be there anyhow. And then I can say self dot name, and this is the instance value, instance attribute, because self belongs to the instance. Self refers to the instance. So when I say self dot name, that means this name belongs to the instance, not to the class. The most important thing. And apart from this particular thing, you can even have some methods. So suppose you have a method called get a name. This is the method. Again, you will have to pass self over here, and you can easily get the name and return that. So you can just print the value over here of the name. So self dot name, something like this, and this is how you can get it done. But when it comes to this self, this needs to be sent. This automatically gets sent whenever you will call this particular method. Why did you learn today? What did you learn today? What did I learn today? Worked on Brainly application. They learned about some hooks in Next.js. Like the hooks are use params. How to get the query parameters, how to get the parameters, and how to get the path name. So use path name. There was something like that hook, and yeah, this thing mainly learned how to use Tailwind with the turbo repo. That was quite tricky for me. So finally, got to know the reason behind that, and now I'm able to use Tailwind with turbo repo. We'll be working on the PTM app with the help of that. And lastly, here I am in Python. I've learned about oops. Like it's done today, and just I'm simply going through the notes to just make sure that I know everything well. We can also the thing is that I've been busy doing household chores, so today it was hard for me to just study a lot, but I still tried my level best. Okay, types of constructors. So there are two types of constructors: default constructors and parameterized constructors. Either you don't give them any value, any parameter, so they'll be the default ones. If you give them the parameters, they'll be parameterized constructor. So a constructor with no parameter except self. Okay, and do you plan microservice? What does does this mean? Sorry, I'm fumbling. Takes parameters to initialize values uniquely for each object. Parameterized or constructors takes parameters to initialize values uniquely for each object. That is right. Learn microservices. In Stack, learn microservices. Never heard of it. Oh, just a sec. Let me keep it. Microservices. Architecture, right? What is this all about? Mobile REST API, web browser, web. So I have mobile REST API gateway, shipping service, inventory service account. Come on, yaar, why are you coming? Really, you don't know about microservices? Yeah, I don't know that. Never heard of it. So how am I supposed to know? Microservices, or maybe I heard, I didn't pay attention. That could be the reason too. So API gateway, store, I'll know more about it. Account services, inventory services, shipping services, and ultimately these are the services that I have. And with the help of the REST APIs, it is just talking to the web app and talking to the get to know more about it. Just looking at it, it can be hard to understand the things. I will be just digging deeper into it. Sorry for this thing, I'm not quite. What are microservices? Let's read through it. Microservices are an architectural approach to deploying a software application as a collection of small independent services that can communicate with each other over a network. Instead of building a monolithic application where all the functionality is tightly integrated into a single code base, microservices breaks down the application into smaller and loosely coupled services. So it is a structure like architecture, can be written in a variety of programming languages and frameworks, and each service acts as a mini application on its own. Amazing. A small loosely coupled service that is designed to perform a specific business function, and each microservice can be deployed and scaled independently. Mm. Do we do the same kind of thing in monorepo? In monorepo, what we do that we have a structure, and in which we can create many apps. There are gonna be different apps, but they will be talking to each other. I don't know. It could be just altogether different one. So breaking system, it is different. It is different from monorepo. In monorepo is a way to just get all the apps together, manage many apps together at the same place, and then import and export the code just among them easily in the better way. Applications of microservice, bank system, e-commerce. Okay. Small independent services built and deployed separately. Each handles business function. Spring Boot makes it easy. Oh, thank you very much, Zohab. You actually make me learn many things. Thanks a lot. How do microservices work? Is ultimately this is the architecture, so I will have to know about the architecture, how the things and all everything is managed over here. But definitely worth giving time. This is a topic that is worth giving time, and I will make sure that I know more about it. The thing is that I haven't even taught this thing in any one of the courses yet, or maybe I haven't completed them well enough, or I forgot everything properly. I can't even believe myself. I may have forgotten. Let's click here. Let's gonna be going deep into it, and I may be just knowing more about it. Okay, let's continue from here on. So note, Python doesn't support constructor overloading directly like Java, C++. Having multiple constructors in the same class, whichever is written last is executed. Think of it as splitting your backend into separate projects, monolithic. Like this. Think of it as splitting your backend into separate projects, monolithic, your current way. One folder, one server, JS, file handling, auth, products and orders runs on port 5000. Auth, products, orders. Okay. Microservices, 3 separate folders, separate projects. App 1 auth runs on port 5001. App 2 products runs on port 5002. App 3. Okay. So my current way is that I run everything on the same port, and this is called microservice, where I can create separate folders for all these, and they will run on different ports. Amazing. Your React frontend calls different ports for different tasks. Your React frontend calls different ports for different tasks. If products crashes, auth and orders keep working. Which watch this video from 19 to 12. Huh? You sent me my own video? Really? You sent me my videos link. 19 to 12 means what? Reload the page. Okay. Watch this video from 19 to 12. Okay. I thought I got my own video. How can it be possible? Okay, super simple Dev. Even the channel is subscribed if I'm not wrong. Yeah, I have already subscribed his channel. I learned JS from, if I'm not wrong. By the way, I copied wrong video URL. That's okay. I gotta just simply save it right now. Of course, I can't watch it, but once the live gets over, I will definitely give it. I will watch it. So let's keep it here. This thing is done. By the way, the most important thing over here, the thing is that in JavaScript, in other languages, we can have multiple constructors, and we can actually overload them. But in Python, we cannot have multiple constructors, and if it is a 10-sec part, bro, just watch it. 10-sec part. 912. What's wrong with the data? Just watch it. Seconds. Oh, come on, yaar. Look. I don't know what's wrong with this. I'm not able to play the video. Something's wrong. And don't worry, I will watch it. Not a problem. I hope just it's not compulsory to watch it right now. Python doesn't support constructor overloading directly. Like Java, C++, we can actually overload the constructors in those languages. But here, if we create multiple constructors, the last one is going to be called or executed. Attributes in OOPS. Attributes are variables that belong to class or an object that may belong to the instance or that may belongs to the class. They store data state of the object. That's right. Types of attributes. Class attributes belong to the class itself, shared by all objects defined outside any method in the class. It doesn't matter which method we have, I will have to define class attributes just outside that. I will definitely watch, believe me, just after this live ends, so I will give it, I'm gonna be watching it. Right now, it's not gonna be appropriate to watch it on the main screen. Belong to the class. Okay, this thing is done. Ultimately, I have created class attributes, and then class attributes can also be accessed with the class name. That is right, with the class name I can access them as well, or I can access them with the help of the instance attributes. Instance attributes belong individually to each object defined inside init method using self. Each object gets its own copy. That is right, and this is how we can just simply create the instance attributes. Continuing from here on, and the next thing is that methods. So methods are functions defined inside a class representing the behavior or action of an object. Bro, reacting to videos comes under fair use. I don't know, I've never done that. Like this. I have seen people live streaming any learning from tutorials. I don't know that. Okay, here it's merely talking about the microservices, save orders, charges. It would be better for me if I actually watch the whole video rather than just not a big deal, bro. Rather than just watching some part of it. So it's saying that I have orders, I have payments, I have email. Instead of having those things running in the same port, I can create three mini apps. I will run those apps in different ports, and I will run different services on those ports, and they will be just talking to each other, something like that. Yeah, I hope so. Well, I'm not turning the audio on right now, just but don't worry, as I've said, I'd better just watch it, I mean the whole video rather than just having the overall idea, because you have already told me whatever I'm getting it here. You already explained everything. Would be better if I just watch it completely. Instance methods. So okay, methods are functions defined inside a class representing the behavior or action of an object. Behavior or action of an object. Okay, instance methods take self as the first argument, can access both instance attributes and class attributes, and this is how I can actually create a display self fname self.name self.marks instance method. Class methods uses @class method decorator, and take CLS class as first argument used to work with the class level data, and this is how I can actually work with that. The thing is that I can actually give it some value, some parameter, and that parameter will be assigned to that, some new parameter ultimately that can be assigned. So school name, and ultimately so I can use class method decorator to create a class method. Static methods use static method decorator. They do not take self or CLS, ultimately class, behave like normal functions but belong to the class for logical grouping and all, and this is how we can even get that thing done. Okay, the most important thing over here, that is 4 things. There are 4 pillars in programming, mainly Python, in all the languages. First one is encapsulation, second one is inheritance, then abstraction, and then polymorphism. We will be talking about all these ones, of course just verbally it will happen, but I'll do my level best to just clear the things. So right now we will be talking about the encapsulation. So encapsulation is the bundling of data, variables, and methods, functions that operate on that data into a single unit class, along with controlling access to the data. This is done to protect the data from accidental or unauthorized modification. Ultimately, what is this? You create a class, you have methods, you have attributes. It's just that once you create the method, once you have attributes and methods inside the class, what you are actually doing? You are actually grouping the attributes and the methods inside the class, and that grouping thing, that encapsulating thing inside a group, that group is the class, is called encapsulation. So it's nothing but bundling the data. What can data be? That data can be either attributes, or that data can either be, or that data can be methods, and you are, with the help of the class, you are just keeping everything inside the class. That means you are bundling them in a group, and that group, that encapsulation is called encapsulation in encapsulation means like we have capsules. So what you are actually doing, that just like there is medicine inside the capsule, so you are actually encapsulating the attributes and the methods in the class, and that encapsulation, keeping the things, bundling attributes and bundling methods inside the class, this process, this way of organizing the thing is called bundling the thing, is called encapsulation. As simple as that. So to implement encapsulation, we use access modifiers. Python has 3 by the way access labels, and again, not only this thing, when you just encapsulate it, even you make them you encapsulate them inside the class, and you even nobody can access them easily. So with the help of public, protected, and private, you just make them not easily available. As simple as that. I hope I'm not facing any network issue and all. That's right. Let's continue from here on. So to implement encapsulation, first of all, encapsulation is the bundling of data and methods that operate on that data into a single unit. Again repeating, encapsulation is the bundling of data, that means attributes and methods, that operate on that data into a single unit, that means class, along with controlling access to the data. So we bundle them, that is okay. We again deal with the authorization thing, like who can actually access this thing. So we control the access as well. This is done to protect the data from the accidental and unauthorized modifications. So ultimately 2 things you can just keep in mind. First thing is that you are bundling. What you are bundling? You are bundling attributes and you are bundling methods inside the class. Second thing, you are even controlling the access of that, like how you can access those instances and or methods by using three things or three protectors, or I can say, and they are public, private, and protected. There are three labels, and you can just give them the label, accessibility labels ultimately. So public means they are gonna be accessible everywhere, so you can just make them public, and that's by default as well, so you don't need to worry about that. Protected members indicated by single underscore, first of all this thing, and protected means they can be accessed inside the main class and inside a subclass. So suppose you have created two classes, one base class and second is the child class. So protected protected methods or protected variables, attributes can be accessed either in the class or in the subclass, not outside the class, neither outside the class nor outside the subclass. By the way, they are indicated by underscore, and we can't really we can access them directly. It is possible to access protected values to in Python. It is possible. In JavaScript or any other language it is not possible, but here it is possible, but it is not recommended, though everything just happens by convention. We make them protected, we make them private just by convention. That means if you really want, you can access even private values outside, but this is not recommended. Still accessible from outside, not truly protected, that is right. Intended for internal use or inheritance, whatever. Okay, then this is how we can actually create protected values. We can access them, but again technically it is not allowed, so you should never access protected values outside the class because that's not recommended. You can access them inside the class or in the subclass. And when it comes to private values, private methods or private attributes, they must be accessed just inside the class. So with the help of the name and under some methods, you can actually get the private values printed outside, but that is again not recommended. Indicated by double underscore, that is the first thing. Python does name mangling. The variable name becomes this and cannot be accessed directly from outside. So by the way, there is something called name mangling, data mangling. And the thing is that using data mangling, you can actually get the data of private variables, private attributes, but you should again never do that. But there is a way, and that can be done. And to access that, we can actually use that name mangling thing, and with the help of that name mangling thing, we can actually get the data. We can actually get private values that we have defined inside the class. Python uses naming conventions with access modifiers, not strict enforcers. Like okay. It's like Python uses naming conventions with access modifiers, not strict enforcement like C++ and Java. In C++ and Java, you cannot access private values and protected values outside the class. But in Python, you can access, and that is not recommended, though that is just by convention. Let's talk about getters and setters. The thing is that when you set the values, like you have made them private, and how will you access them outside? And how will you even like assign them the value? For that thing, we have getters and setters. Getters are gonna be used for getting the values. Setters are gonna be used for setting the values. Again, they are just normal functions, so you don't need to worry about that. Normal instance functions. So getter and setters are just normal instance function, and they are just related to that particular instance, not to the class. So it's just like that. So if I have an employee class, I can have a constructor, and inside that constructor I can have some private values. I can make, suppose I have salary, so I can make salary private, and using the getter function, get salary function, I can get the salary. And because private attributes can be accessed inside the class, so in get salary function I can access that, and from set salary function I can actually set that too. So it's simple, easy peasy. So getters and setters. Getters means for getting, setters means for setting, as simple as that. And it is mainly used for two things. First one is for protected and second one is for private. Mostly for private values. Can be used for both. Inheritance. So first one thing we have learned, that is encapsulation, and that is pretty much easy peasy. Encapsulation means you are encapsulating. What you are encapsulating? You are encapsulating attributes and methods. How you are, where you are encapsulating, in which thing you are encapsulating, you are actually encapsulating it inside the class. So you are ultimately bundling the attributes and the methods inside the class, and doing this thing is called polymorphism. And one more thing is that you are not just only bundling them, you are even making sure that whether they are accessible or not. So whether the attributes or methods are public, private or protected, you are even taking care of this particular thing. And this particular process doing this particular thing, making bundling and making them accessible is called polymorphism. Sorry, encapsulation. And the inheritance, anybody knows about it, by the way. Inheritance is where one class acquires the properties and behaviors of another class, as simple as that. Ultimately, if there is a parent class, the child class can actually extend parent class and get the values of the parent class. The class whose properties are inherited, they are called parent, base, superclass. You can call it any. That can be called parent class, that can be called base class, that can be called superclass. Because using super method, you call the constructor of the parent class, so that is also called superclass. And the child, you already know, child class, derived class, or subclass, that is also the thing. So there are a few good namings over here. The parent class can be called parent, base, or superclass. The child class can be called child, derived, or subclass. Let's continue from here on. You can actually create two classes, and they can just simply inherit, like extend each other. The child class can extend the parent class, and this is how you can just get the stuff done. Inheritance enables code reuse, because you can actually access everything that is inside the parent class. Extensibility, that is right, cleaner, maintainable design and all. Polymorphism. What is polymorphism? Polymorphism is a poly means many, morphism means forms, so many forms. So that means once you are actually overriding the method. Suppose you have a class, that class has a method. Okay, similarly you have another class, that class also has a method. And right now you have parent class, you have child class. Child class extends the parent class, inherits all the properties of parent class. So now parent class has a method named, suppose greet, and the child class also had the same method greet. So what is happening over here? The child class is actually overriding the method of the parent class. So this overriding thing, when one class overrides, first of all, when one class extends the other class, and with that child class actually overrides the method of the parent class, that overriding thing, overriding functions, overriding method, this particular thing is called polymorphism. So we will be even going to there are two things in polymorphism mainly. First thing is overriding. You override the functions. Which functions will you override? The child class will override the functions of the parent class. So first of all, it will extend, it will get all the functions, and then when it can override, it can make the functions the way it wants them to be, and that process is called overriding, and that is called polymorphism. Polymorphism is, poly means many, morphism means shapes, so many shapes. So there are many shapes. The parent class has its own the shape, like parent class also has that same method. Child class also has that same method, but they are doing two different things, as simple as that. And the second thing is that duck typing. Duck typing in the sense they behave the same and they do the same. Ultimately, how can I explain? Let's go to that particular topic, then I will be talking about that. By the way, here I am mainly talking about inheritance, and there are three types of inheritance. First of all, single level inheritance. That means there is a parent class, there is a child class. Child class extends the parent class, that is called single level inheritance. Then there is multi-level inheritance. There are two parents. There are three things. There is suppose grandpa, then your father, and then you. So you extend the property of your father extend the properties of your grandfather. So this is called multi-level inheritance. Now, first of all, your father inherited the properties of your grandfather, so that is called single level inheritance. And now you are extending the properties of your father, so that is now multi-level inheritance. Crazy. Okay, so we learnt about single inheritance, where one child class or subclass inherits the values of properties of methods of the parent superclass or base class, parent class, whatever you want to call that, you can call that. Then we have something called multi-level inheritance. It's easy peasy, and when one class inherits the value of the parent class, and again that in the child class has again another child class, subchild, whatever you call that. A child inherits from parent and another class inherits from the child, as simple as that. Then we have something called multiple inheritance. So first of all, single inheritance, you already know that a child inherits the properties, methods from the class. Multi inheritance means the level is the child is inheriting the properties from the parent, and then again another child is inheriting the properties from the child itself. That is called multi-level inheritance. And there is something called multiple means there are many classes. There is something called what there is one class, there is another class, and then both of them are extending the property. Just like we have a teacher class, we have a student class, and there is something called TA, teaching assistant. So teaching assistant can inherit the values of, can inherit the attribute and methods of the teacher as well. Teaching assistant is a teacher as well as a student in a college, of course. So TA inherits the values of the or properties of the teacher, and TA inherits the properties of the student as well. As simple as that. This is called multi-level inheritance. And we can of course call super keyword to call the parent class method from child class. Again, when it comes, because parent methods, they will actually have the constructor and all. So if we wanna call the constructor, so how will we call that? Using super method. Super is used for calling the constructor of the parent, as simple as that. Then what is abstraction? Abstraction is hiding unnecessary implementation details and showing only essential features to the user. We may have lots of unnecessary implementation, but we will only show what is needed. And mainly abstraction is used for what can I say? Abstraction class is mainly used for a structure. Abstraction mainly gives you structure, that okay, this is the structure, this is the structure that you have to follow. And using this structure, if you extend any abstraction class, abstract class ultimately, so if there is any class, that class is extending another class, and that class itself is the abstract class. That means whatever abstract properties or methods that abstract class has, you will have to just mention all those class in the inherited class, that means inside the child class. So abstraction class mainly defines the structure of the class. So if you are actually extending the abstract class, that means you will have to define everything in the class that belongs to the abstract class. Crazy stuff, but yeah, go through it and you will understand it better. So abstraction is hiding unnecessary implementation details and showing only the essential features to the user. Example can be simple. In real life, when we drive a car or press the brakes, the car stops, but we don't need to know how the hydraulic system works. That's reading it out. To implement the same idea in Python, we have abstraction. We implement abstraction with abstract classes and abstract methods. Okay, we have abstract methods, we have abstract classes, and we can extend them. And when we extend them, we will have to make sure that we are actually defining everything inside the child class. An abstract class in Python is one which cannot be instantiated. That is just a structure. That is not the real class that can be called class. But it's not like it cannot be instantiated. Like if you have a class, you can instantiate the object and instantiate the class and get the instance and get the object. But you cannot do the same with the abstract class. So just keep this particular thing in mind. Can contain normal plus abstract methods. When it comes to abstract classes, at that time they can have abstract methods, and if they have some abstract methods, that means you have to have those abstract methods in the child class as well. But they can have normal methods as well, and those normal methods will only belong to the abstract class. You can define those classes in the child class, or you may not, it's up to you. But an abstract class can have two types of methods. First one is gonna be abstract, that must be there in the child class, that must be redefined, that must be mentioned inside the child class. But the normal function that you create, the normal method that you create, that need not to be like behave like that. Usually acts as a blueprint for child class. As I said, it is just a structure, it is a blueprint. It says that okay, you have to have these methods, you have to have a grid method, you have to have a calculate method, you have to have a sum method, you have to have a multiply method. That is it. And if you make them abstract methods, that means they have to be present in the child class anyhow. By the way, for this particular thing, there is something called ABC module. We can just from ABC module we can import ABC, that means abstraction based classes. So we can import abstraction based classes from ABC module, and with the help of those abstraction based classes we can that is actually the abstract class, abstraction based classes. Then we can simply inherit that abstract method. Okay, that is it. Great stuff. So I can create an animal class. That animal class inherits the ABC, and then it has some abstract methods as well, and that is like def sound in self and all, that's okay. Abstract method, it is a method declared but not implemented. Children must override abstract method. That's what I was saying, that if you are extending any abstract class, you will have to have, or you will have to override the abstract methods that parent class have. That is the must, a must. So just keep this particular thing in mind, and then we can just simply go ahead. So abstract methods we have discussed, and one more thing is that if you actually wanna define a abstract class, because in JavaScript you can just simply write abstract and the class name and done, but in Python it does not work like that. In Python you will have to import ABS module. What is this ABS module? Sorry, ABC module, not ABS module. ABC module means abstraction based classes. You will have to import this module, and with the help of this particular module you will actually create the abstract class. Once the abstract class is created, you can keep some methods, abstract methods or normal methods. Normal methods, they don't need to be overridden in the child class, but abstract methods, they need to be overridden in the child class anyhow. That is just like the blueprint they are. And once you have created your abstract class, then you can simply, the child class can simply extend the abstract class, and while extending, the child class needs to make sure that it is actually using it is actually overriding all the abstract methods that are inside the abstract class, something like that. So this thing is done, by the way. This is how we can create the abstract methods using the abstract method decorator. So that thing needs to be there in the mind. And then lastly we have polymorphism, and once we have gone through polymorphism, then we are done. What is polymorphism? I already told. It is the ability of single function, operator or object to behave differently based on the context. Poly, many, morphism forms. The operator is same, the function is same, okay, or the object is the same, but that function, that operator, that object behaves differently in different places, in different situations. So polymorphism, that means many forms. And the idea is that same method name, ultimately method name is going to be the same, that will be working differently for different objects. It will be just simply working differently in different situations. Same operator behaves differently depending on the operand types. Again, operator is the class itself as well, like everything in, I can even check this particular thing out, whether the operator is a class or not. So let's get this thing over here. Let's keep it here, and like this I can get rid of this particular thing. And what I want, that I want to check the type. So print type of plus. Well, this is not really plus. Well, you cannot really check the type of plus, that is just an operator, don't worry about that. So same operator behaves differently depending on operands. So this thing is done. Same plus operator being used for two different operations called operator overloading, that is right. Plus operator is being used for two different operations called operator overloading. That's great. Let's look at two popular overriding polymorphism. Again, two popular types of polymorphism. There can be many types of polymorphism anyway. By the way, here we are gonna be, maybe it has two types. First one is function overloading, where you are actually overriding the functions, and the second one is that duck typing. We will be talking about that. You can call it function overriding, or you can call it method overriding. When a child class provides its own versions of a method that already exists in the parent class, both methods should have the same name. Parent class has a method, child class has the same method. Child class is simply overriding the method of the parent class. That is called function overriding. And type of runtime polymorphism, dynamic binding. Type of runtime polymorphism, dynamic binding. Child method takes precedence over parent class. That is for sure. A child will always be ahead of his father. Okay, so what happens, that child methods, they have more priority than the methods of the class, the parent class, as simple as that. So the child method takes precedence over parent methods. That is simple thing. And then we have something called duck typing, and that is the last thing. works on the idea if it looks like a duck and quacks like a duck, it must be duck. If something looks like a duck and that quacks like that, speaks like a duck as well, so it must be a duck, as simple as that. So it's the same over here. What it actually means that there's gonna be a method, and maybe just speak method, and I will actually have, first of all, I have a dog, I have cat, I have robot, and on top of that I will have something else. Just a sec, something is missing over here. First of all, I will have to create a method. I can just discuss the same thing over here. If I actually go to this particular slide in here, can keep it this thing here, and where can I keep the remaining thing? Okay, so what I wanted to say that if I go to my notes and let's talk about the class code, and lastly I want to talk about the duck typing. So ultimately what is happening over here, I'm not talking about the overriding thing, I'm rather talking about the duck typing. So when it comes to duck typing, so there can be two methods with the same name, and they will be doing the different things. So ultimately they look the same, they behave the same. Ultimately they seem to be behaving the same, but ultimately the result is different. So that is all about duck typing. The thing is that, first of all, when it comes to polymorphism, so there are two things that we have to keep in mind. First one is function overriding. A child class can override the functions or methods of its parent class, and that is called function overriding, and that is again that is the first type of polymorphism. And second one is duck typing. Duck typing in the sense they will look the same. So suppose I have two classes, I have a class called dog, I have a class called cat, and both of them have methods, a method called speak. So dog class I also have a method called speak, cat class also have a method called speak. So they both of them have the same class speak, they look the same, it seems like they behave the same as well, but ultimately the result is going to be the different. That's another case, but this is called duck typing. Like both of them they are different classes, but they have the same methods, and that same thing, they look the same, they appear the same. That appearance, that looking the same, is called duck typing. Ultimately duck typing means they look the same and they quack the same, like they ultimately behave, it seems like they are behaving the same, as simple as that. So this is how everything is done. We have actually learned about 4 things over here, and that was all about OOPs. So when it comes to OOPs, so the thing that we have to keep in our mind that object oriented programming, and there is something called keeping everything inside a class. So in object oriented programming we have class, and we try to connect it to the real world. This is the most important thing behind using OOPs, because we have procedural programming as well. So we have a procedural way of mentioning the things. We can simply use functions and do not use OOPs, but that will still work, but OOPs is a better way. And when it comes to OOPs, so there are a few things that you have to keep in mind. First of all, there are 4 types of things that happen inside the OOPs. First one is inheritance, second one is abstraction, third one is encapsulation, and fourth one is what the hell, I've forgotten. Encapsulation, then inheritance, abstraction, and polymorphism. So these are the 4 things that actually happen over here in the OOPs. And what is that? There is something that I wanted to discuss. Come on, I've forgotten that. Crazy stuff. Let me have a look at that again. What is that? Not object oriented programming, not even classes. Not worried about the classes and all. Okay, I think I missed that. Never mind. There was something like okay, never mind. Let's talk about these 4 things. I think that is something that I wanted to discuss. So in OOPs, what happens is that there are 4 things that you have to keep in mind. Mainly in OOPs there is class. The class can have its attributes. The class can have its methods. Similarly, there is something called instance. Whenever you instantiate the class, you get the instance of the object or the object, and the instance itself can have its own methods or attributes. And there is something called static method, that is just a normal function. You don't need to worry about that, you can just simply create that. and using some decorator. So for static methods you will have to use static decorator. For class methods you will have to use class decorator, and normal instance method, for instance methods you don't need any decorator for that. One thing you need to keep in mind that you use self parameter over there, and in class methods you use a CLS parameter. So this is the thing. CLS stands for class, so don't worry about that. And the next thing that you have to keep in mind that when it comes to object oriented programming, so there are four pillars of OOPS. First one is inheritance, or let's start with encapsulation. Encapsulation is simple, encapsulating the things. What do you encapsulate? Encapsulate means bundling them. What do you bundle? You bundle the attributes and you bundle the methods. How do you bundle? You bundle them inside the class, and that is called polymorphism. And you don't only bundle them inside the class, you don't only group them inside the class, rather you define, or you said that whether they are publicly accessible or not with the help of three labels: public, private and protected. So this particular thing, bundling them inside the class and giving making them accessible outside or restricting them, is called encapsulation. Ultimately you are encapsulating them inside the class. What are you encapsulating? The attributes and the methods, and you are giving them the labels public, private or protected. This particular thing is called polymorphism, encapsulation. Let's talk about inheritance. Inheritance is simple thing. A child class can inherit the values of parent class. Okay, so there is three types of inheritance: single level inheritance, multi-level inheritance and multiple inheritance. Single means a child class simply extending the parent class. Multi-level inheritance means a child class inheriting the parent class, and the parent class also inheriting its own parent class. So it's like there is a class, there is a child class, the child class is inheriting the values of the parent class, and there's another class that is actually inheriting the child class too. So it's just like that. So this is called a multi-level inheritance. And there is multiple inheritance, like there are many classes and there is a child class. The child class is inheriting multiple classes, so it's simply extending multiple classes, as simple as that. So this thing is also done. And after inheritance, so we have learnt about encapsulation, we have learnt about inheritance. Now it's time to learn about abstraction. What is abstraction? Abstraction is all about keeping the implementation hidden and just give the right result. The way we just press the brakes in the bike or in a car, and everything happens automatically. We don't exactly need to know exactly when you press the brake what happens. Similarly, what abstraction means that you hide everything, unnecessary things. Just give me what I need. And when it comes to abstract classes, so what abstract classes do, they simply give you the blueprint, like this is the blueprint that you have to go with, and don't worry about anything else, as simple as that. So when you create an abstract class, even for creating an abstract class in Python, you need to import a module called ABC module, that means abstraction class module, and ABC abstraction based class. This is the module that you have to import, and once you have imported it, so you will be getting ABC object, ABC class, and you will be getting abstract method decorator. So these two things you will get from that particular module. And once you got these two things, so first of all you can create a class with the help of ABC class. You will extend that ABC abstract class, of course, and with the help of abstract method, you will be able to create the methods, abstract methods. And once you have created the abstract class and abstract methods, then you can extend a child class can actually extend that particular abstract class. And one thing needs to be kept in mind, that when you are actually extending an abstract class, so all the abstract methods, there can be normal method inside abstract class as well, but all the abstract methods that are inside the abstract class, they need to be overridden, they need to be redefined, they need to be mentioned inside the child class. That is the must. So it's all about abstract classes. And lastly we have polymorphism. Polymorphism means poly means many, morphism means forms. So the forms are gonna be many, and the look is going to be the same. So suppose I have a function called getName that gives us the name. So ultimately that's the same, right? GetName. There is a class called there is one class. There are two classes and they have a same function called getNames. So what is happening that they have the same names, but that's doing the different thing. that is called polymorphism over here. And especially when it comes to polymorphism, so there are two types of polymorphism. First one is function overriding, second one is duck typing. So function overriding means a child class simply overrides the methods of the function and changes the things for its own use. That is called function overriding. And again, the name of the both the function methods are gonna be the same. It's just that the child class is actually overriding that. But again, there are two methods. They actually do the different things, and ultimately child class is actually overriding that. So this is called function overriding. And lastly, something called duck typing. What happens is that there can be two classes. Those two classes can have the same two methods, and if the name of those two methods are same, so ultimately they look the same. Those two methods look the same, and because of that thing, that is called duck typing. And this is again another type of polymorphism. So these are the four things that we have actually learned today. And the next thing that we will be doing tomorrow, actually we will be actually solving questions using these. So today what we learned, today we mainly focused on actually just going through all of this, and these are the examples anyway that I have just simply written over here. So I don't even need to go through these examples. That's okay, I'm alright with this. Tomorrow we will actually be solving the questions using this the topics that we have covered today. So first of all, we have gone through it, then we have some assignments that we have to go through, and this is how we have to just simply go ahead with the things. Hope I'll be able to just get them done in the better way possible. And this particular thing needs to be removed. Alrighty, so this thing is done. Let's remove this particular thing from here. By the way, I never expected myself to be just live for this long. It's been 1 hour and 41 minutes. I was supposed to be live just for 40 minutes, and I happen to be live for one more hour extra. But the good thing is that we have actually completed it, and nothing could be even better than this thing. And now I can just simply stop doing this. Like I can just end the live right here. And as for the remaining things, I will be getting them done tomorrow, so don't worry about that particular thing. We will not leave anything behind. And this was the thing that I was learning, and this thing has already been covered, so I can just get rid of this thing. So let's get rid of this. And as for this one, even I have to just go through the other stuff and all. So tomorrow we will be simply solving the questions and learning the other things as well. Mainly I will be learning the things about strings and all. And this is how things are gonna be going on. And then at last I'm yet to learn about the file system and all, but it's not like that's difficult. The file system is easy. And then there are many things, like it's not like there's just only one thing. But that will be done, not a big problem. What do I have inside this? Alrighty, I've gone through it. That was it for today. Now I'm gonna be catching up tomorrow. And today, of course, we learned about oops and everything's clear. Right now, there are only questions to be solved. So we will be solving the questions tomorrow. And this is how the things are gonna be going on. Until then, good night. See you and take care. Bye bye.